You all here? Those at YouTube, can you all hear me? Okay, great. You all here? Those at YouTube, can you all hear me? Okay, great. You all here? Those at YouTube, can you all hear me? Okay, those on YouTube, if you can see the screen, just put some thumbs up so I know. Okay, bagus. Thank you very much. Okay, good then. Okay, thank you. Okay, we will start in a while. Okay, just give me a second. In a while, we will start live. Okay, now before I move on and carry on with the lecture today, I just want to check the technicalities over here today. So you all can hear me, right, on YouTube and on the Zoom? Okay, very good. For YouTube, can you all hear me? If yes, then please say yes. I think there's around 34 or 35 of y'all in the YouTube right now. So if yes, please say yes. Okay, good then. So I think everybody can hear me lah. Okay, good. So I can see yeses over there. Okay, so we are going to continue back again from 1.2 where we stopped just now, and from lecture 1 lah. So wherever we stop in lecture 1, we are going to continue again lah. So I hope everybody can be ready lah. Okay. So from here, what I see right now, I have 97 of y'all with me. Okay, so I hope the 97 of y'all can be ready, and hope the balance who are supposed to be coming in should be coming in soon lah. Okay. For the YouTube, I just request you all just keep on commenting so that I know that you all are there and I know the thing is working lah. Okay. So where we stopped just now was here. We will be starting back again from here. Okay, addition and subtraction finished. Now multiplication. Okay, so we will be starting from multiplication. So please be ready. As far as I know, there are a few people who wanted to join. You are welcome to join, no problem. Okay, so right now we have 100 of y'all here ready. Okay, so I think start. Okay, ready? So welcome back to lecture 2, and we are going to start right now for lecture 2 and carry on from the lecture 1 there just now, previous one. We are going to do multiplication. Okay, we are going to do multiplication of complex number. So it's not that hard actually, it's quite easy. Let's see over here. 3 minus 4i and 4 minus 3i. So these are the two complex number which is given to us, and we are going to multiply this lah. So I understand it's quite an afternoon. Okay, 3 o'clock. Time to have lecture is not that good actually, but yeah lah. We have to carry on because it's a class. Okay, so 3 times 4 here. 3 times 4 is going to be 12, and then 3 times 3i over here is going to be minus 9i. Then negative 4i times 4 here is going to be negative 16i. Okay, and negative 4i times negative 3i there, this is going to become positive 12i squared. Okay, now I need to let you know that when I give you square root of negative 1, you can tell me the answer is what? Come on. Square root of negative 1. What is the answer going to be? Class? Yes, that's right. That's what we know. Yes or not? And that was defined to you in lecture 1. So now, if I give you negative 1 over here, negative 1 is going to become I squared. Agree until here? Negative 1 is going to become I square over there lah. Okay, negative 1 will become I square. So we know this from here that negative 1, okay, is I square. So from here I can write down 12 minus 9i minus 16i plus with I square. So what is the value of I square? I square value is negative 1. So here I'm going to put negative 1 lah. So instead of writing just negative 1 there, I'm going to put here 12 times negative 1. Can understand here so far? Good. Okay, so can see that line. Okay, now from there we can do this. We can take 12, okay, minus 12 minus 9i minus 16i. So 12 minus 12 there is directly going to give me 0. Okay, and minus 9i minus 16i is going to give me negative 25i. Everybody okay under here? Anybody got any question inside here? So far, so good. Any problem under here, class? Okay, if no problem, I carry on. Okay, so that's how multiplication is done. Now, before I go on to division, I just want to give one more or two more examples for multiplication so that we are in the same page and I can know that everybody understands. So let's see 3a here. I put for multiplication. This is 3a. I extend the question. B, Z1. I give you 3 minus 4i. And if I give you Z2 is the conjugate of Z1. So if conjugate of Z1, what is going to be the conjugate of Z1 going to be? What is the conjugate going to be over there? Can you please let me know? Yep, class. Conjugate of Z1, what is it going to be?
3 plus 4i.
Yes, correct. 3 plus 4i over there. So the conjugate is going to be 3 plus 4i. Yes or not? Okay, now if I'm telling you I want to multiply Z1, multiply with conjugate of Z2 there, I mean Z1, basically is 3 plus 4i. So I'm going to get here 3 minus 4i and 3 plus 4i. And if you really look over here, this is going to be 3 times 3, which is 9. 3 times 4i, which is 12i. Okay, then 4i times 3, negative 4i times 3, negative 12i, and negative 4i times with 4i there. So this is negative 16i square. Agree with that? Okay, it's normal expansion over there. Okay, normal expansion. So from here, you can tell me this is going to be 9 minus 16. I square is negative 1 because I already told you just now, square root of negative 1 is I. Therefore, negative 1 equals to I square. Okay, so 9 minus 16 times negative 1. 12i and 12i will cancel off because they are the same. So here I'm going to get 9 plus 16, which is just 25. Done. Okay, that's all. So what we can conclude over here is, I can conclude that if a plus bi, okay, and times with a minus bi, okay, we can get this as a times a square. Okay, it's supposed to be minus b I square, b square, I square. Yes or not? Minus b square, I square, because bi times negative bi. So it's going to be minus b square, I square. But because the I square is negative 1, so from here I can tell you this is just a square plus b square. So if I times with the conjugate, you can conclude this formula over here. Can you understand under that, class? This is the formula which we can conclude. Okay, of course, this expansion you all studied before already. A minus b, a plus b. That becomes a square minus b square. Okay, that becomes a square minus b square. So everybody understand under here, right? Any problem under here so far? Yes? Yeah, see? Very good question. Okay. Venusha asked me that for exam, shall I show the whole working, is it? It depends on the particular question. If they ask you to multiply only, then yes, you have to show the detailed working. But if let's say they just ask you to take the conjugate, you are supposed to use the conjugate and multiply to get the answer, then you can do a little bit faster, no problem. Because this one is, when you multiply with the conjugate, you just show that you are multiplying with the conjugate, then you can straight away go to a square plus b square. And even if you show the whole working also, no problem. Okay, I hope I answer your question. Can? Okay, Venusha, I hope I answer your question. Okay, good then. Let's carry on. Okay, so from there, I move on. Okay, I can go on some more. I can maybe give you C. Okay, maybe I give you like this now. Okay, 3 plus 4i, that is maybe for Z1. Okay, are we using 3 plus, we just use 3 plus 4i. Let's change the number to bit line, make it more complicated. 2 minus I. Okay, and then I give you Z2 over here. Z2, let's take it 4 minus 3i. Okay, so of course you're going to take 2 minus I times with 4 minus 3i. So if I multiply this thing, 2 times 4 here, I'm going to get 8. Then 2 times negative 3i, I'm going to get minus 6i. Negative I times 4 is minus 4i. And negative I times negative 3i, I'm going to get positive 3i squared. So from here, you get 8 minus 6i minus 4i plus 3. I square is what? Oh, negative 1. So from here is very obvious. 8 minus 3. Okay, minus 10i there. I'm trying to do it a bit faster a bit. So I get the answer here. Any problem until here so far? If my calculation goes wrong, please let me know, because this question I just created. So sometimes when we are doing calculation can go wrong, human mistake. Okay, I hope until here everybody okay. Any problem until here so far, class? No, okay, good then. Yes, who have problem? Yes, Hatta. I dah explain tadi, I square itu jadi negatif 1 kerana ini. If you look over here, square root negative 1 is I. So square root bring over akan jadi I square kan. So I square must equals to negative 1 lah. From the formula of square root negative 1 is I. Clear? Okay, I square jadi negatif 1 kerana ini. Definition square root negative 1 sama dengan I. Boleh faham Hatta? Okay, bagus. So saya gerak lagi lah. Okay, I move on. Okay, I move on here. Now, we go back to division now. Now we go to the next part, which is called division. Now, actually, complex number division is basically multiplying by conjugate. We want to get rid of the denominator, which is complex there. We don't want the denominator to be a complex number. So if I give you 4 minus 3i, what is the conjugate of 4 minus 3i over here? Yes, anybody can help me? What is the conjugate of 4 minus 3i? 4 plus 3i. Very good. So if this is 4 plus 3i, so here also is 4 plus 3i. Why I times with 4 plus 3i top and bottom? Because it's actually equivalent to 1. So I did not change the question. Okay, I did not change the question over there. So I hope that is clear for everybody. Okay, now from here, if I multiply, I get 3 minus 4i, and then 4 plus 3i over 4 minus 3i, 4 plus 3i. So you can see over here, if you notice over here, this is a minus bi, this is a plus bi. So that's the formula which we saw just now, yes or not? Okay, that is one of the formula which we saw just now. So, and I told you this can be written as a square plus b square. And the explanation is already given before this. Okay, so now when I can write down that, so here I don't need to go and calculate so much. I know my answer. I know my answer, which is going to be 16 plus 9 then. Am I right? 16 plus 9. But if you're not sure, you want to expand and then calculate, no problem. Okay, if you want to expand and then calculate, no problem. Nobody stop you. Okay, you can still do that. This is just to make it a bit faster. Okay, so from here you get 3 times 4. 3 times 4 is 12. 3 times negative 3i, so you get 9i here. 4i times 4 here, so you're going to get negative 16i. And 4i times negative 4i times positive 3i, so you get negative 12i squared. Okay, so again from here I can see that I'm going to get 12 plus 9i minus 16i minus 12 negative 1 over 25. Okay, so if I look over here, negative is going to become positive, yes or not? So 12 plus 12 is 24 minus 9 minus 16, yes? 9 minus 16 is going to be negative 5i, am I right? Or no? Can I just get confirmation? Is negative 5i there? 9 minus 16. Oh, yes, sorry, my mistake. Thank you. At least I know some of you all are awake over there. Some of you all commented back, but some of you all no comment, so I'm just wondering. Okay, thanks. Okay, hopefully you all managed to understand under here over 25. So when I write down the final answer here is 24 over 25 minus 7 over 25i. Boleh faham sampai sini semua? Anybody got any question under here so far? So division of a complex number is basically multiplying with the conjugate. Okay, division complex number is basically multiplying with the conjugate over there. Boleh faham semua? Okay, nak kita buat lagi satu. Okay, we do one more example for division. Okay, let's see Okay, this is B. If I give you Z1 equals to 3, don't want 3 anymore bosan. 2 minus 3i, and then Z2 there is going to give you 4 minus 5i. So now I'm going to put like this, Z2 over Z1. I put Z2 over Z1. Okay, if Z2 over Z1 here is going to be what? 2 minus 3i. No, wrong. Z2 is going to be 4 minus 5i over 2 minus 3i. So if I want to divide this thing, so what shall I do to divide? Okay, what shall I do for dividing now? To divide this thing here, I have to take the conjugate lah. So 2 plus 3i and then 2 plus 3i. Okay, bagus lah. Kalau faham, bagus. Okay, good then. So from here, I get this ready. Now I multiply. So 4 minus 5i and then 2 plus 3i over 2 minus 3i, 2 plus 3i. Okay, jom kita tengok soalan ni sikit lah. We expand this thing. I get 8 plus 12i minus 10i minus 15i squared over, the bottom there, you can expand straight away. Yes or not? So 2 times 2 will become 4. The negative is going to become negative 9, but then got I square. The I square is going to become negative 1. Remember that lah. So from here, you're going to get 8, okay, minus 15 times negative 1, okay, plus 12i minus 10i. I arrange everything already. So from here, you're going to get over 13. So 8 plus 15 there, 8 plus 15 there is 23. Plus with 2i over there over 13. I can write back this as 23 over 13 plus 2 over 13i. So let's say if they ask me to compare with a plus bi. So you can very clearly tell me a is 23 over 13 and b is 2 over 13. See, you can straight away compare and tell me this. Huh? Any problem under here so far? Everybody can understand this? If yes, then please let me know. Respond back to me a bit. Boleh Okay, good. Ada soalan sampai sini? Kalau ada, tolong tanya. Lebih banyak you tanya, lebih baik untuk saya. Kalau you tak ada soalan, saya nak tanya. Okay, if Z is 3i, yes?
If the final answer can be simplified, you need to simplify.
Yes lah, of course lah. If final answer can be simplified, you have to simplify lah. Okay, if final answer can simplify, you still have to simplify. Understand? Okay, can ah? Okay, bagus. Okay, now I want to ask you, if I give you Z equals to 3i, apa conjugate dia? If Z equals to 3i, what is the conjugate? Can I know? Yasmin, Hakimi, boleh answer? Apa? Yes, negative 3i. Conjugate for 3i is negative 3i. Okay, conjugate of 3i is negative 3i. But how if I give you Z equals to 3? Conjugate dia apa soalan mencabar ni.
Zero.
Zero lah. Bukan zero Conjugate dia 3 jugalah. Conjugate dia 3 juga. Kerana 0i, yes or not? Plus 0i minus 0i is the same thing, right or not? So that's why it's just 3 lah. Boleh faham tak? Okay. So that makes me know that you understand lah. Okay, that makes me know you understand the meaning of conjugate over there. Okay, so boleh saya gerak lagi? Okay, so untuk lebih detail, you boleh scan QR code ni. Daripada QR code ini, you boleh dapat lebih maklumat lah. Okay, you boleh dapat lebih maklumat. No conjugate, correct Ariana. That one have no conjugate, but you still can write down 3. Okay, actually not say no conjugate, the conjugate is 0i, that's all ni lah. Okay Ariana, Daniel, I hope this is understood lah. Okay, boleh faham Okay, sekarang saya mula lagi. Next one there is called the Argand diagram. Ready for here everybody? I give you 1 minute to stretch up and ready for the next part lah. Okay, Argand diagram. Now, Argand diagram is the most interesting part in the complex number lah. Okay, complex number, it came out from De Moivre's theorem. De Moivre's theorem. De Moivre. If I'm not mistaken, this is the spelling. Okay, you can Google after this. Okay, De Moivre's theorem. And every complex number, we can represent this in under an Argand diagram. Okay, under an Argand diagram. What is the difference between Argand diagram and Cartesian diagram? Argand diagram, we have imaginary and real part. Okay, Cartesian diagram, we only have x and y lah. This is x, this is y. Sorry, my mistake. This is x, this is y. Okay, this is x, this is y. Okay, so this is our Cartesian diagram, normal Cartesian diagram. This is just an Argand diagram. Okay, an Argand diagram, the circles, if I want to draw for the graph, okay, it will be like this. Dia sebenarnya macam ni. Okay, this is how argon diagram looks like lah. Okay, of course lah, we got a lot of lines over here some more. Okay, but right now we are not going to draw this complicated because it's going to be very hard for us to understand. So we just try to represent this in the form of a Cartesian diagram. Okay, we try to represent this in the form of a Cartesian diagram with just telling that the y-axis is imaginary, the x-axis is real lah. Selalunya saya suruh budak ingat adalah we pijak di bumi yang nyata. Okay, kita pijak ke bumi yang nyata. Nyata maksudnya real lah. Okay, step on the real ground line. Don't go towards the, what is it called, imagination world lah. Okay, the imagination world will be above what, right? Not so that's why the imagination world is at the top. So I hope this is very clear lah. And under the coordinate of A, B over here, A here will always represent the real number. Okay, and B here will represent the imaginary number. So we know that this coordinate here is A and here is going to be B lah. Okay, that is what our AB represents over there. So I hope that is clear for you all. Okay, and R is represented of the length of OP. So the length of OP over here, this length over here is the R. Okay, R is actually just the length. Okay, R is just the length. So if I ask you right now how to find the length when you have a right angle triangle here, this is definitely right angle, right? Am I right? This is definitely right angle. So if I ask you how to find the R, I'm very sure all of you all can be able to answer me. There is one theorem which we have been using for past many years, since Form 2 you all have studied. So yes, anybody can tell me what is the theorem which we will use to find R?
Pythagoras.
Yes, that's right. The great Pythagoras theorem. Okay, the great Pythagoras theorem. So we will use the Pythagoras theorem to find R. And another one more way to represent R, we can write down this as R modulus. We can write this as what? R modulus of R. So modulus of R also means length. Okay, modulus of R also means length. Okay, so if I go here now, okay, we can represent the complex number in a form of a polar form. Okay, we can represent the complex number in the form of a polar form. Okay, and polar form is written as R cos theta plus I sin theta. Okay, R cos theta plus I sin theta. I look at the yellow color one. This is what we want. Okay, this is what we want over here. So R there is the modulus. R here is the modulus, which we get by using theorem Pythagoras. R here is the modulus, which we get by using theorem Pythagoras. Okay, so use what? Pythagoras theorem lah. Okay, PHY. Pythagoras theorem. Okay, Pythagoras theorem. So that's how basically we use to get R there. Okay. Now the theta there is the argument. Okay, the theta there is the argument. Okay, so let's see how we can use theta lah. Okay, theta here is argument and theta is represented in the form of radian. Okay, is represented in the form of radian or is defined as radian. Okay, such that from here to here is from 0 to pi. And from here to here, okay, is from 0 to negative pi. So it's only until pi. From, if let's say we go anti-clockwise, is going to be positive, and if and what is it called, clockwise is going to be negative over there. So I hope you all understand here. Okay, don't worry. After this, when I show example, you'll be more clearer. Okay. So if I ask you what is the polar form, okay, polar form of a complex number, you have to give me this thing, lah. Okay, and I prefer this thing to remember as R cheese. R cheese, the rat which chase the cheese. The rat which chase the cheese lah. Why? Because the R there represents the modulus, C there, cos, I there is the imaginary for the sign lah. So plus I S lah. Understand? So rat which chase the cheese lah. So R cheese lah. I remember that way lah. Okay, just a way to remember. Everyone have their own way to remember. So if you prefer another way, go ahead, no problem. Okay. So let's see the next one lah. Okay, we carry on some more. Here, I already told you all that the R there is represented by theorem Pythagoras, where I can tell you the R formula is a square plus b square square root. Okay. Now, one more thing we can know from here is I can write down this thing over here. If I push down, okay, if I push down, this is going to give me r cos theta. So r cos theta, if you look over here, r cos theta is going to be a. Okay, r cos theta is a, and r sine theta is going to be b. And we also know that sine theta over cos theta is going to give me tangent theta. Okay, means r sine theta, r cos theta is going to give me tangent theta. R and R will cancel off, right? Which is going to give me b over a. Okay, which is going to give me b over a. So this is something which we need to take note lah. Okay, this is something which we need to take note. Okay. And again, I stress again, the theta is defined from negative pi to pi. The theta is defined from negative pi to pi. When we go towards the top, is 0 to pi. And if we go towards the bottom of the real axis, 0 to negative pi. Of course, theta is defined in metrics from negative pi to pi. If you look at a different, what is this called? Different syllabus. Sometimes if you look in IGCSE, sometimes if you look in Cambridge, maybe they define theta differently a little bit. Okay, they define from 0 to 360. No problem, can, possible. Okay, but in metrics, this is how it's defined. So when you see a different book, don't get scared line. We follow how the argument is defined in metrics. And it have to be in radian. So make sure your calculator mode is in radian. Make sure your calculator mode is in what? Radian over there. Okay. So now I think I will try to do a few questions here first. Okay. Before I go, let's look over here. We try and see here. Okay, if I give you z equals to 3 plus 4i. Okay, 3 plus 4i. So you can tell me, I can draw an Argand diagram like this. The a here is going to give me 3. And the b there is going to give me 4 there. Yes or not? Okay, the b is going to give me 4. To find the r is not a problem. To find the r is just going to be, or before I find the r, I write down first. This is going to be 3 cos theta. Another one more r is going to be 3 cos theta. And the other one more is going to be what? Sorry, my mistake here. R cos theta is going to equals to 3. And r sine theta is going to equals to 4. Okay, we know this already lah. Okay, we know this. So from there, I can write down this, that r square is just 3 square plus 4 square, square root, which is 9 plus 16 square root, which will give me square root 25, which is 5. Done. No? Can I understand that, everybody? Any problem? Because r is length, what? R is length, so from there, I can get the length already. Okay? Just be careful one thing, if they put negative 4i, later you have to put negative 4i, you cannot put 4 square there. Okay? Now comes to the angle part. So the angle which I want to find is here. So if we want to find the angle is there, I can write down this as tangent theta, which is basically sine theta over cos theta, which will give me 4 over 3. Okay, so let's put theta. What is theta going to be? Press your calculator right now. Everybody should press your calculator. Okay, please press your calculator, everybody. Come on. If you press your calculator, you can tell me what is tangent theta going to be over there. So shift tangent 4 over 3. But make sure your calculator answer is in radian. So can I get the answer from you? Can I get the answer from you? Yeah, 0.9273. Okay, so correct, 0.9273. That is in radian. Okay, sometimes you can get a proper fixed answer if you give decimal answer, so not a problem. Clear? So now I can write down this as z equals to, my formula is r cos theta plus I sine theta. The thing which I asked you all to remember was cheese, RCIS. Okay, R cheese lah. So R there we know already is 5. Cos theta is what? 0.9273 plus with I sine theta again 0.9273. That's it lah. Put a big bracket over there so you can see your answer is correct already. I hope until here everybody okay. Any problem until here? Those in Zoom, please mute your mic, can? Thanks, Akif. Okay, and those in YouTube, are you all okay? All ready? Any problem? Any problem until there so far, class? Okay, good then. So if everybody okay, I hope everybody can understand here lah. Okay, at the YouTube one, can you all comment back please so that I know you all are okay? Belum lihat komen lagi sekejap okay, all good. That's right. Okay, okay, no problem. Okay, Fatin Hazira, no problem. Okay, so I can carry on line. Okay, bagus. Now let's go to the second quadrant. If you look at the second quadrant, I give another one more example here. So I maybe put negative 3 plus 4i. Okay, I put negative 3 plus 4i. Purposely lah Okay, there's a reason for this. So let's see lah if negative 3 plus 4i over here, we know the A is negative 3. We know the B is going to be 4 lah. We know that already, right? Not? Okay, because the coordinate is here, negative 3 plus 4i. Okay, the coordinate is there lah, negative 3, 4. Betul tak? Negative 3, 4, coordinate 2 kat situ. Okay, okay, now from there, we want to find the R. So R, no problem. Negative 3 square plus 4 square. Tolong jangan tulis 3 square. I know the answer is going to be the same, but it's not allowed lah. In exam, your working is wrong. Understand? Based on the question, your working is wrong. So R equals to 5 over there. I hope this is clear. Then we write down. Okay, when we write down this, we can know that what is this called? R cos theta equals to negative 3 and R sine theta equals to 4. Now, if you see this thing here, then you will get tangent theta equals to 4 over negative 3. Sekarang kita ada masalah sikit. Okay, our argument is from here to here. That is our theta. This is what we want. We want to find this theta here. Yes or not? Okay, we want to find this theta here. So for me to find this theta over here, if I'm going to use shift tangent 4 over negative 3, I'm not going to get my answer. Okay, if I just use shift tangent 4 over negative 3, okay, I might not get my answer lah. Okay, I will get negative 53.13, or if I change to radian, will be negative something 0.927. Okay, so I want the answer to the answer which I'm going to get. I'm going to find alpha first, which is my basic angle. So whenever we want to find basic angle, we don't press the negative. Understand? Alpha is my basic angle. Remember, whenever we want to find basic angle, we don't press the negative. So if you press without pressing the negative, you will press now tangent shift, shift tangent 4 over 3 there. I'm very sure you all get 0.9273. Everybody agree with this? Agree with this, semua? Yes. But what is the argument going to be? The argument of z over here, the argument of z, which is also equivalent to theta, is going to be shift pi or pi minus 0.9273. That will give you 2.214. 2.2143 radian. And the argument is positive. Why positive? Because it's above the x-axis. Theta is your argument of z. Remember, theta is your argument of z. Here, theta is equivalent to alpha. That's why the argument of z over here is the same or as theta, which is 0.9273, which is also the same as alpha, the basic angle. Can you understand here? So when we see this condition over here, when got negative, we have to find the basic angle first. After we find basic angle, then to get theta over here, let me just write down here maybe in more detail. You get pi minus 0.9273. That will give you the answer 2.2143 radian. I hope until here you all are clear. Any problem until here so far, class? Boleh faham?
Okay.
Okay, bagus. So if I want to write in polar form, of course lah, how to write in polar form? Polar form, z equals to r. R is what? R is 5 cos 2.2143 plus I sine 2.2143. Done lah. Polar form lah. This is my polar form then. Boleh faham sampai sini semua? Ada soalan sampai sini? Kalau tak ada, saya boleh teruskan. Boleh teruskan? Boleh kan? Okay, saya teruskan. Okay, saya teruskan yang ketiga, third quadrant. So if third quadrant, the A also must be negative, the B also going to be negative. Yes or not? The A also is negative, the B also is negative. So let's see over here lah. Okay, I give one lah, negative 3 minus 4i. I'm doing the same thing again, just to see the difference over there. So you know that here is negative 3 and negative 4. The coordinate is here. So B is negative 4 here. Here is negative 3. Okay, so R no problem lah. Kalau you tengok negative 3 square plus negative 4 square, square root. So I'm very sure you get here 9 plus 16 square root. So you can tell me square root of 25, which is 5 lah. Tengok this time I use negative 3, negative 4 square root. Square, then ni square root. Yes or not? So kalau, what is this called? You guna 3 square campur 4 square akan jadi salah lah, because jalan kerja salah. Okay, jalan kerja salah. Saya harap ni clear. Lepas itu always write down this line, always write down this. R cos theta equals to negative 3. R sin theta equals to negative 4. So you know that tangent theta is going to be what? Oh, sine over cos. Sine over cos is negative 4 over negative 3. Tangent theta is 4 over 3. But remember again, the argument is here. This argument is equivalent to z. Okay, argument is z over there. Clear? So to find the alpha over there, alpha is your basic angle, yes or not? So to find the basic angle, what we have to do? We press shift tangent lah. So shift tangent 4 over 3 is going to give me 0.9273. Yes or not just now? Yeah, 9273. Okay. So argument of z atau theta is going to be pi minus 0.9273. But remember, because it's below the x-axis, we put a negative here. Because it's below the x-axis, we put a negative there. So from here, this will give me negative 2.2143 radian. I hope until here you all are clear. Boleh sampai sini? So argument of z is negative this time. Okay. R adalah 5. So when you write in polar form, pay attention here very carefully. In polar form, when we write down z equals to 5 cos negative 2.2143 plus I sin negative 2.2143. Okay. Saya dah tulis macam ni. Harap nampak. But be careful here a bit. Here we have to write back again 5. Okay. Cos 2.2143 minus I sin 2.2143. Now why? Because we know that cos negative theta sama dengan cos theta. Tapi sin negative theta adalah sama dengan negative sin theta. Boleh faham sampai sini semua? Because of this, okay, because of this rule over here, the cos just change the number ni, no negative sign outside here. Understand? Cos negative theta sama dengan cos theta. Tapi sin negative theta adalah sama dengan negative sin theta. So kalau dalam exam, you biarkan jawapan sampai sini, sebenarnya tak ada masalah. Jawapan you masih betul. Okay, memang dalam polar form, memang betul lah jawapan you. Clear? Tapi kadang-kadang dia suruh compare, then you maybe they ask you to compare like this. They put a negative outside there, then you have to be able to compare lah. Okay, atau kadang-kadang dia beri macam ini. So you should be able to understand the thing lah. Okay, you should be able to understand the thing. Any problem until here so far, class?
No, sir.
Ada soalan? Tak ada Okay, kalau tak ada soalan, saya pergi kepada yang seterusnya. Okay, this time I give a different number lah. Okay, I give a different number. Z equals to, don't want 3 anymore line. We take what? 4i, 4 minus 7i. Boleh? Okay, 4 minus 7i. Okay, Amelia tanya kalau jawapan boleh dalam pecahan tak? Boleh, tak ada masalah. Okay, kalau pecahan boleh, tak ada masalah. That's why sometimes you press your calculator, you dapat pi per 3, boleh. Tulislah cos pi per 3. Okay. But make sure dalam radian. Dia mesti dalam radian. Dia tak boleh selain daripada radian lah. Okay, dia tak boleh selain daripada radian. So saya harap faham lah ini. Okay, so let's see the next one there. Okay, next one, Z sama dengan 4 tolak 7i. So if Z equals to 4 minus 7i over here, I know the A is going to be 4. Okay, A 4, here negative 7, coordinate dia 4, negative 7, sebelah sini lah. Okay, sebelah sini. Boleh nampak kan? Okay, for negative 7 there. So Z R dia sekarang, R dia adalah 4 square plus with negative 7 square, square root. This is 16 plus 49. You square root this thing. So 49 plus 16 there. 49 plus 16 there. You get square root 65. So let's just leave the answer as square root 65 lah. Tak perlu nak tulis dalam decimal, boleh, tak ada masalah. Okay, you can just leave the answer as square root 65 over there. Because if I divide by 5 also is 13, yes or not? So both also are prime numbers, so cannot take the square root properly lah. Okay, we leave that as square root 65 there. Then we want to find the theta. Again, you write down r cos theta. Okay, r cos theta equals to 4. R sin theta equals to negative 7. Remember? Okay. But again, remember this thing. Here is going to become tangent theta equals to opposite of our adjacent. Or you know this is negative 7 over 4 lah. Sine over cos, right? Not sine over cos. So if you look over here, now this time theta is also your argument of z. But the theta is only here. So again, we don't need to press the negative. So we actually supposed to put modulus. Okay, we're supposed to put modulus over here. So theta over here is actually argument of z. So if you press shift tangent 7 over 4 there, you straight away will get the answer in radian lah. Okay, you all can calculate in radian. Can you please give me the answer? I expect the answer from you. Anybody? Shift tangent 7 over 4. So I know your calculator mode is correct.
1.05.
Yes, correct. 1.052. Okay, 1.052 radian lah. Okay, so we know that this time the argument of z is which is theta, but remember the theta have to be negative lah. Why? Because it's below the x-axis. So what I prefer here is I prefer to find alpha first lah. When I find alpha, I know it's 1.052. Then only I write down theta argument of z equals to negative 1.052 over there. Why? Because this make me sure that my answer is negative there is correct lah. And I can check again. Oh, look, below the x-axis, negative here. So I hope you understand how to get the argument. Anybody got any problem until here so far? Now I agree, different books have different style. Different lecturers also have different style of defining the theta. And I see what inside your YouTube maybe is a little bit different also. But it's not a problem. Understand everything. The answer is still the same. The final answer is still the same. Everybody have their own style. Okay. So once you get this ready, now we go to polar form. Okay. Under polar form, I know this is square root 6. Z there can be written as square root 65. Okay. R there we know the cos theta, cos negative 1.052 plus with I sine negative 1.052. Okay, we get this already. So here I get square root 65 cos 1.052 minus I sine 1.052. That's my final answer. Why again? I repeat, why is this the case? Because cos negative theta equals to cos theta. Maka for the cos, it just changed the negative, remove lah, the negative disappear. Okay, but sine negative theta equals to what? Negative sine theta. That's why the negative have to take out lah. So when negative you take out, you get negative over there lah. Positive negative becomes negative. Okay, sampai sini okay tak semua? Saya harap semua okay lah
Sir,
Ya, ada soalan?
apa ni video dia macam leki, macam lambat sikit.
Dekat mana? Dekat YouTube ke?
Dekat sini lah.
Oh, okay. So, sekarang saya berhenti sampai mana?
Saya dah berhenti tapi dia still tertulis. Macam dia lambat sikit lah.
Oh, okay. Sorry kerana itu adalah masalah internet. Saya pun tak boleh buat apa-apa. Saya guna Unify ni, tapi tak tahu. Okay. Saya juga guna dekor ni, dekor yang dia suruh kita beli kan. Saya pun beli. Tapi yalah, itu masalah internet. Tak apalah ya.
Boleh terangkan balik tak yang dalam bilangan negatif theta ada theta?
Okay, ini adalah formula untuk trigo. Cos negatif theta sama dengan cos theta. Betul tak? Okay, ini adalah formula. So, bila ini adalah formula, cos negatif theta ini, bila kita akan tukar kepada cos 1.052 because formula kata this negative will disappear. Okay, the negative will disappear. Sebenarnya, if you take cos negative of an acute angle, okay, is the same as cos acute angle lah. And sine negative of an acute angle is the same as negative sine of the acute angle. Boleh faham tak? Kerana cos theta itu dia jatuh kat sini kan. Over here, cos is going to be positive, what, right or not? That's why. Tapi ini adalah formula trigo lah. Ini adalah formula trigo yang sepatutnya kita dah tahu lah. Okay. So cos negatif theta sama dengan cos theta, sin negatif theta adalah sama dengan negatif sin theta. Saya harap saya jawab soalan. Senang nak ingat, if you really want to see the easiest way to remember, cos ini dia tukar kepada positif, betul tak? Tapi negatif ini, negatif sin ini, sin negatif theta ini, negatif ini dia keluarkan lah. So bila dia keluarkan, negatif kat sini dengan positif kat sini, positif negatif jadi negatif lah, itu aja. Tengah-tengah itu je berubah kalau ada negatif argument. Argument negatif, tengah-tengah itu jadi negatif. Argument positif, tengah-tengah kekal positif. Boleh faham? Okay, bagus. And tapi kalau dia suruh tulis argument Z, then you must write negative lah You cannot write positive 1.052, wrong in this case here, argument Z will be negative 1.052 Okay, boleh Okay, let's see here lah. Okay, kita ada satu soalan kat sini, kita cuba. Okay, we draw this line here first. 2 set 3 plus 2i. So, kuadran mana? Pertama, kedua, ketiga atau keempat? Mana satu? 1, 2, 3 or 4? Of course, 1 lah, right not? So, here, we mark 2 set 3 plus 2i. I can draw this. I can label here as 2 set 3. And here, I can label as 2. R, I'm very sure you can find 2 set 3 square plus 2 square. Square root, ini akan dapat 4 times 3 plus 4. 12 plus 4 is 16. Square root of 16 is going to be 4 lah. Okay, because R is length, okay, R is defined as length, therefore, and R got modulus, right? That's why we only take the positive lah. Okay, modulus of R. Sometimes dia tulis macam ini saja, modulus of Z. Modulus of Z sama dengan R lah. Modulus of Z is the same as R here. Let me just write back again. Modulus of Z sama dengan R, sama dengan ni. So kadang-kadang dia tak tanya apa itu R. Dia hanya kata find modulus of Z. You must know lah. Modulus of Z is actually R lah. Understand? Modulus of Z is actually what? R over there. Okay. Itu benda pertama. Kedua, we have to find the theta right now. So R cos theta sama dengan 2 set 3. R sin theta sama dengan 2. So tangent theta sama dengan 2 over 2 set 3. Cancel. 1 over set 3, right? So theta, you can press your calculator. Shift tangent 1 over set 3. Apa anda dapat? Cari semua. Okay, what you get there? Anybody can tell me what's the answer? I'm still waiting for your answer. Hello? Are you all with me? 1 over 6 point. 1 over 6 what? 1 over 6 pi. Right or not? 1 over 6 pi radian. And then we know that the argument is from here to here what? So theta sama dengan alpha sama dengan 1 over 6 pi radian lah. So argument of Z sama dengan 1 over 6 pi radian. Okay, kalau you nak, saya boleh tulis ini sebagai alpha juga. Tapi I think it's okay lah Okay. So bila tulis dalam polar form, Z sama dengan length dia tadi apa? 4 kan? 4. Okay, for cos 1 over 6 pi plus with sin, I sin 1 over 6 pi radian. There you get the answer. Sekarang saya nak tanya satu benda boleh? Kalau dia bagi polar form, you nak tukar balik kepada normal form into a normal complex number. You want to change back to complex number. They give you polar form, you want to change back to this standard complex number. How? Macam mana? Apa you kena darab? Darab sajalah 4 cos 1 over 6 pi. Tekan ini semua dalam kalkulator anda. Campur with I 4 sin 1 over 6 pi. Tekan ini semua dalam kalkulator anda. If you press that in your calculator, you will get back the same answer. Boleh faham sampai sini? Saya harap video saya tak lagging. Lagging ke, kelas?
Medium.
Lagging Saya ulang balik.
Ha.
Okey, saya ulang balik. Sekejap Oh, lagging sikit Sekejap, saya ulang balik If I take this thing, I want to change back to the standard complex number. What can I do is basically, I press 4 cos 1 over 6 pi, the whole thing in the calculator. Okay, and then I press 4 sine 1 over 6 pi in the calculator also. So when I press both of that in the calculator, I will get back 2 sub 3 and 2i. Agree with this or not? So you don't believe, you can press right now 4, you tekan 4 cos 4 cos 1 over 6 pi. Tekan lah. You mesti dapat balik 2 sub 3. Okay, you will get back 2 sub 3 or in decimals lah if your calculator doesn't support fraction functions lah. Okay, but if you press 4 sine 1 over 6 pi, you will get back definitely, you will get back 2i over there. You will definitely get back 2i over there. Okay, saya harap faham semua. Kalau ada soalan, tolong tanya. Okay, saya berhenti sekejap supaya apa yang saya cakap dengan video itu selari dulu. Okay, semua faham? Ada soalan? All okay? Anybody not okay still? All okay Okay. So sekarang ada dua example sama here. Okay. Minus 1 plus I there. I try and do lah. Okay. I try and do. Okay. Saya lukis sini. So negative 1 plus I. Which quadrant is it going to be? Negative 1 plus I. Quadrant 1, 2, 3 or 4? Negative 1 plus I. Yes lah. Quadrant 2. So this is going to be negative 1 and here 1. So here is going to be the coordinate of negative 1, 1. And we draw this way. You can see? See, I pijak ke bumi yang nyata. Daripada koordinat itu, kita pijak kepada bumi yang nyata sikit lah. Okay. Saya harap faham lah semua. Saya nampak lagging juga. Saya tahu. Okay. So, argument which we are going to find is from here to here. This is the argument of Z which we want. Okay. Or which is equivalent to our theta lah, which we want to find. Okay. The thing which we have to find first is our alpha here. Okay, we need to find our alpha here. So I can write down the R first, which is negative 1 square plus 1 square square root. So dapat 1 plus 1 square root 2 over there. Saya harap semua okay sampai sini. Okay tak kelas? Boleh tak? Okay. Boleh Okay, now from there we know this already. Now we have to find the tangent alpha. So kalau kita dah banyak kali tulis R cos theta sama dengan negative 1, R sin theta sama dengan 1, kita boleh nampak lah ini adalah 1 over negative 1. So basic angle is alpha there. Kalau you press shift tangent 1 over there, I'm very sure you're going to get fraction button is going to be what? 1 over 4 pi. Yes or not? Can you all calculate that for me, please? Everybody get right? 1 over 4 pi. Yeah. Okay. And we know that the argument is positive. So the argument is 1 over 4 pi. To write back in polar form, I write down 1. Set 2. My mistake. Set 2. Okay. So sine. Why I write sine? Cos. Cos 1 over 4 pi plus I sine 1 over 4 pi. Dapat jawapan. So that is our argument over there. Saya harap semua orang faham lah. Okay. Yasmin, betul jawapan you tadi. Sorry, saya lambat nampak chat anda. Saya harap anda semua okey lah Dekat YouTube itu ada 38 orang. Saya harap semua okey. Zoom pun ada 71 orang. Okey, ada lebih kurang 109 orang kat sini lah. Okey. Ya. Yeah. Saya tak dengar. Apa?
Kan jika dapat alpha kan.
Ya. Yeah. Oi, kita dapat alpha. Ya. Sorry. Ya, betul. Terima kasih. Hujung-hujung ini saya pun dah kabut sikit Okay, thank you Okay, ini adalah theta, ini adalah argument z. Thank you very much. So here is pi minus 1 over 4 pi. So you get 3 over 4 pi. Yes or not?
Yes.
So 3 over 4 pi. Thank you very much for correcting me. I'm very happy when you correct me. Why? This shows that you are paying attention in my class lah. Okay, selalunya tolonglah correct saya. Saya pun bukan perfect Okay, you should correct me whenever I'm wrong. Okay. Terima kasih siapa yang betulkan saya tadi. Terima kasih banyak-banyak. Okay, I carry on some more boleh I go to example 8 there now. Okay, example 8, I go on. Negative 1, negative I. So negative 1, negative I here, you get here. Because negative 1 here, negative 1 here. So this is the coordinate there, negative 1, negative 1. This is what we want. This is the alpha. So again, R is going to be negative 1 square plus with negative 1 square, square root. So dapat square root 2. Now once we get this ready, we get R cos theta sama dengan negative 1, R sin theta sama dengan negative 1. So from here, tangent theta sama dengan 1 lah. Okay, here again theta, or basically alpha Okay, alpha is going to be what? Opposite over adjacent there, pi over 4 lah. Your basic angle is going to be pi over 4. But remember, argument is from here to here. So argument of z, which is so equivalent to theta, is going to be pi minus pi over 4, which is 3 pi over 4. Okay, so from here, writing back again, remember the argument must have what? The argument here must have negative. Why must have negative? Because it's going below the x-axis. So negative lah dah. Boleh faham sampai sini semua?
Yes, sir.
Boleh Okay, so from there, polar form. Apa itu adalah polar form? Polar form is going to be set to, here is going to be what? Cos, if I do fast a little bit like 3 pi over 4 minus I sin 3 pi over 4. Semua orang tahu kan macam mana saya dapat negatif itu? Kerana argument je negatif. Kalau argument negatif, tengah-tengah mesti negatif. Boleh faham?
Yes.
Okay, bagus dah. Okay, yang kat YouTube itu boleh faham semua?
Sir,
Yeah?
is it okay if I leave the argument in decimal form?
It is okay, no problem. They never say that you should give in what is this called? Fraction only. But it's wrong if they ask you in perfect answer. If they say exact answer, leave your answer in exact form. Okay, if exact form, set 2, you must write set 2. 3 pi over 4, you must write 3 pi over 4. If they use the word exact form, then you are wrong. And that is what most of the time they do in, what is this called? In exam lah. In exam, we know that student is going to give us decimal. So we purposely lah tell them, give the answer in exact form. Then you are wrong already lah. Or unless, if let's say it's objective, then objective questions, they don't give you fraction. They give you in, they don't give you decimal. They give you in exact form. Then you must be able to answer that also lah. Clear to that? I hope that's clear. I answer your question. Okay, I'm taking time to remember your names. So, yalah, 100 plus names to remember in 3 or 4 days is not that easy lah. Okay, especially when nearly all your names are the same. Saya ada entah berapa Nurul kat sini Nurul. Fish. Saya nak remember semua pun susah. Okay, tapi saya akan cubalah. Okay, saya akan cuba. Okay, kalau tak ada masalah, this is for more details. You can scan and you can start doing question number 5 to question number 17. So next week we have tutorial until question number 17. All of you all should be ready lah. Or anything involving complex number, everybody should be ready lah. Okay, so until L2, your lecture notes should be ready also. I hope until L2 nobody got problem and everybody can ready by next week tutorial until number 17 only. Any problem until that class?
No.
Okay, very good. If no problem, I stop here today and I will see you all back on Monday lah. Okay, I will see you all back in on Monday. Happy weekend. Enjoy doing my homework and have fun. Okay, the YouTube video is still at the YouTube channel, so you can always refer back again. Okay, I hope if I did any mistake, sorry, because I'm first time using StreamYard also. Uh, and I really hope that we can continue this momentum till the end. Okay, thank you, class. Bye.
Thank you, sir.
Thank you very much.
Thank you,
Thank you,
sir.
sir. Thank you, sir.
Okay. Yeah.
Thank you, sir.
Okay. Thank you.
Recording stopped.